Select the best series of reagents to accomplish the following transformation. So we see, and we've already labeled here, that we have an ester that we're starting with. So we always want to look at functional groups, and we are forming a secondary alcohol. So we want to say, okay, we've definitely got a change in functional group, and we also want to see, do we have a change in the carbon skeleton? And we can see with our ester, we don't appear to have that OCH3 in the product anymore. I would imagine that this oxygen from our alcohol is likely from the carbonyl, is what I would suspect. So I want to be able to identify the remaining carbons of the ester here in the product. And so I am going to number, not in an IUPAC way, but I'm starting at an end because I see that that oxygen is in the middle of the molecule. So I can see that I have 1, 2, 3, 4 carbons. So I'm really just trying to trace, like, these 4 carbons are these 4 carbons is my goal. And then I see 5, 6, 7. So we have added a 3 carbon atom chain. And our new bond is also a new carbon-carbon bond. So we have a kind of limited toolbox for forming carbon-carbon bonds. So seeing that this new carbon-carbon bond is where it is in terms of the fact that the new bond is to a carbon that is an alcohol, this makes me suspect organometallic attack at a carbonyl. Because if I were to take a carbon nucleophile and attack a carbonyl, I would end up with an alcohol as a product. So here's what I would do in breaking this backwards. So I've got a pencil, which is a nice way to approach these sort of problems. And I'm going to assume that carbon 5 was nucleophilic and carbon 4 was an electrophilic. And I'm basing that again on the fact that I see the oxygen. And I know that if I put a carbonyl there, that would in fact make carbon 4 electrophilic. So if I erase that bond, and I take this back to being a carbonyl, there it is. And specifically, I should recognize what type of carbonyl that I have here. So I've got the 4 carbon atoms. I can only see 3 bonds to this. There's also a bond to hydrogen. And that was also present here if we want to go back and draw it in. So we have this 4 carbon atom aldehyde, and then we need a 3 carbon atom nucleophile, so some sort of metal. Probably something like a Grignard reagent is a good idea. So let's look at that as an option. So our question then, if we're considering this as our retrosynthetic pathway, is do we know a way to take an ester and to make an aldehyde? So I'm going to draw the aldehyde as its key intermediate. I think this is really the way to go with this problem. So you want to think, can you do that selective reduction? And hopefully you would remember the reagent Dibal, diisobutyl aluminum hydride. And if you do that reaction at -78 degrees, you can take an ester and selectively reduce it to an aldehyde. And then this aldehyde, we're saying if we could get a Grignard reagent, the appropriate 3 carbon atom Grignard, then we could form that alcohol product. And we should add in a few details. This is technically the first step is a 2-step process. So you're going to have a quench with water. And again, in this second step, this would be, I guess, technically step 3. And then step 4, you're probably adding in water or aqueous acid, something along those lines. And so I would try to solve it first and then look for my answer and hopefully find it so that I don't have to go painstakingly through every step. And I see Dibal here right away. And I can see that, yep, that's the same 2 steps we indicated. We've got a 1, 2, 3 carbon atom Grignard and then an aqueous workup.